Building APIs is an invaluable skill in the world of software development and data engineering. Whether you're building a backend for a front-end application, exposing an inference API for a machine learning model, or something entirely different, APIs are essential. In this video, we will create a high-performance API in Python using FastAPI and connect it to Postgres using SqlModel. We'll then deploy our application to Kubernetes using Kustomize and Helm. Let's go! Our application has several components and moving parts. Before we start coding, let's understand the design. Feel free to skip ahead if you prefer jumping straight into the code. The core component is FastAPI, a Python package that provides an asynchronous and fully typed interface for writing REST APIs. This is what users will interact with when making requests. For our Postgres connection, we'll use SqlModel, a powerful package from the same developer as FastAPI. It leverages SQL Alchemy and Pydantic under the hood to provide a fully typed interface for database communication. Once we've built our application, we'll tackle deployment. We will containerize our application using Docker and wrap it in a Kubernetes deployment with multiple replicas. A service will act as a load balancer for these replicas and provide the IP address for our users. As a bonus, we'll also deploy Postgres using a community Helm chart. If you are not planning to code along, feel free to skip to the next chapter. If you are, there are a few prerequisites you need to code along. First of all, a UV installation for Python development. See my previous video on how to get started with that. It's linked in the description. Secondly, we will need Docker for containerization. I use Docker Desktop, which is the easiest way to get Docker up and running. Optionally, if you don't already have a Kubernetes cluster available, you can enable Kubernetes in Docker Desktop. This gives you a local Kubernetes cluster, which is absolutely perfect for development. We will also need a few CLI tools. First of all, kubectl, which we will use to interact with our Kubernetes cluster. We will need Kustomize, which we will use to template our deployment for our application. And optionally, if you don't already have a Postgres instance available, Helm, which we will use to get a Postgres database up and running on our Kubernetes cluster. With that out of the way, we can start building our application. Let's start by creating our API package. We will use UV init package to set up our project structure. We can see that the structure has been created correctly. Side note, my tree command is just an alias for an ESA command. I use ESA as a drop-in replacement for ls. For this project, we'll need just a few dependencies. The standard extra includes the FastAPI CLI and UVcorn for our async HTTP server, while scikep-g2 binaries handles Postgres connections through SqlModel. Our application consists of two main components. The first is a table model with database connection. While traditionally we'd use a combination of Pydantic and SQL Alchemy separately, SqlModel now provides a high-level interface that reduces boilerplate while still using both packages under the hood. Open up your favorite editor and let's create our database model. In model/pokemon.py, we will define our SQL model. By setting the ID as an optional primary key, we can let Postgres generate a new ID when creating an entity. Using default factory, the model automatically inserts the creation timestamp. We will add two basic fields called name and number, and lastly, an enum called region. We'll create a new db.py module to handle database connectivity. In here, we'll read Postgres credentials from environment variables, initialize the engine, and create a function that yields a session object. Now, let's build our backend using FastAPI routes. To keep our code organized, we'll use FastAPI's router instead of putting everything in one file. Let's create a route package with a Pokemon.py module. We'll create a router and prefix all endpoints with /Pokemon to avoid repetition. Now, newly created main.py, we will create a FastAPI application and register our route with the app. Our Pokemon router needs 4 key functions. Create Pokemon accepts a Pokemon model and returns a Pokemon with a newly created ID. Get Pokemon returns a single Pokemon. Delete Pokemon removes a Pokemon. And List Pokemon returns a list of all Pokemons. While we could directly supply a depends object with the getSession function to the endpoints, this kinda limits code completion since the editor can't determine the type. Instead, we will wrap depends inside an annotated object, providing context for type checkers and enabling better code completion. Now we can directly supply this new session type to all the functions. And we have all the code completion that we need. Now let's finally implement all the endpoints. When creating a Pokemon, committing the creation refreshes the object with the Postgres generated ID. Getting a Pokemon is rather straightforward, and we return a 404 if the ID isn't found. For deletion, we can actually reuse the getPokemon function and re-raise any exceptions. Finally, we can query all Pokemon with our list function. Back to db.py. To ensure that our tables exist when the app starts, we will add a createDB and tables function. This reads all registered models, currently just Pokemon, and executes the necessary create table statements. We will use a lifespan context manager to run this at startup. Getting our app into Kubernetes requires a Docker image. Thanks to UV and FastAPI, this process is really straightforward. We'll extend from the 3.12 Alpine image, pulling the UV binary from the Astral image. We'll set up our working directory, copy the required files, run UV sync to create the virtual environment, and pass the no dev flag to make sure that we don't install any dev dependencies. And lastly, we set our command. Building is as simple as running a docker build command. We are now nearly finished. We'll use Kustomize for our Kubernetes setup, a powerful tool for declarative and modular configuration. While we only scratch the surface of its capabilities, it's perfect for our needs. Our application needs 4 key components: a namespace, a secret containing our Postgres connection details, a deployment with 3 replicas, that also includes a selector, a reference to our Docker image, an image pool policy set to never, which is very suitable for local Kubernetes clusters. For remote clusters like Azure Kubernetes, you'll need a less restrictive policy like if not present. And ensure your image is available in a registry like Docker Hub or Azure Container Registry. We will also reference the secret that we created earlier. And lastly, a service acting as a load balancer, using the selector to route traffic appropriately to our pods. We are almost there. If you're running locally without Postgres, you'll need to deploy it. Kustomize allows us to reference Helm charts. So instead of building our own Postgres setup, we can use the well-maintained Bitnami chart. We'll only customize the Postgres credentials through our values file. After setting up the Helm chart, we'll reference our 4 Kubernetes YAML files as resources. And now we can deploy everything with Kustomize build and then pipe it into kubectl apply f. Let's verify our setup with kubectl get pod. The pods are running. Excellent. To get access to the API, we need to port forward a service to a local host. If we now visit localhost 8080/docs, we can test the API through its interactive documentation. Let's try creating a new entity. Notice the auto-generated ID and created add fields. Let's add another Pokemon. We can also list all Pokemons. We can get a single Pokemon by ID. And of course, we can also delete the Pokemon by ID. Everything works perfectly. While we've built a solid application here, there's plenty of room for expansion. Here are some exercises you might try. Let me know in the comments if you like a follow-up video covering these implementations. You could add a CI pipeline for code linting and Docker image building. You could implement some pre-commit hooks. You can add unit tests, which addresses challenges like making requests with PyTest, using an in-memory database for testing instead of production Postgres. Create a CD pipeline for Kubernetes deployment with rolling updates. And perhaps for the ambitious, implement proper database migrations with Alembic. And there you have it. We've built a modular FastAPI application with SqlModel, running multiple replicas in Kubernetes and communicating with Postgres using SqlModel. The foundation is set. Now it's your turn to build something amazing. The sky is the limit. Happy coding!